Hello, my name is John Egnatis, and in this video, I'm going to be presenting my programming calculator project written in MIPS assembly language. So before I jump into the code, I'd like to explain a bit the test file. So as you can see, the test file, you can have lots of inputs, but each line represents one input. And basically how it works is it's decoded. So you have this lowercase B, D, or H, which represents binary, hexadecimal, or decimal input. Then we have the 7, which represents the amount of digits, excluding spaces, negative signs, whatsoever. So that's 7 digits right here. And then the output. So this is going to be changed into a hexadecimal number in the output. And you can include things such as negative signs, and also for this number, for example, this is implicitly signed negative because the 32 bit, we're using 2's complement, I should say. So let me jump into the code. All right, so this is my MIPS code. It's going to be run in Mars IDE. And I cannot show the actual code because it's a school project, so I could run into problems there. But I'm going to go ahead and compile this. All you have to do is write the text file, and for the Mars IDE, you just have to put the text file in the same directory as the Mars jar executable. Basically, you run this, and you can see all the test files are entered. So we give one example right here, decimal right here. Let me see if I can. So we have decimal 256 was entered. That's a decimal number. And then it prints out right here the hexadecimal value, which would be 100. All right, and finally, I'd just like to show some of the solution analysis. So right here, for example, we have binary negated of this number, 1001, 0011. See if you negate that right here, turns into this number in 32's complement, which is negative 147. And that is right up here. This one right here. And then we have another one. Then a few more. This is actually a double negation because the 8 right here represents negative in 2's complement, and this negatives also. So if you see you negate it, you negate it, and it's already negative, so it actually returns a positive number. You can see here in the decimal that's positive. All right, and then finally I'd like to show some of the appendix. Right here, as a binary input, you can only enter 1 or 0, obviously, decimal 0 through 9, and then hexadecimal 0 through 9, and A through F. All right. And then also the input constraints, I explained about this a bit earlier, but the first character must be a lowercase b, d, or h. The next number is an input length due to the 32th complement. We can only have numbers 1 through 32, and for binary, 1 through 10 for decimal, 1 through 8 for hexadecimal. And then the last character obviously has to be uppercase. And then one more thing to note: if you are inputting a decimal number, it cannot go out of this range, because then it'll return, it'll be overflow. And then this, I've already explained this earlier, but implicit and explicitly signed, you can take a look at that. And so yeah, that'll be all for today. Thank you so much for listening, and have a nice day.